Hello there, this is a geometry video. It is chapter 10, section 2, and today we will be discussing measuring angles and arcs in circles. So just to give you some vocab here from the onset, we have a central angle of a circle is an angle with a vertex in the center of the circle. So we have here an example of a central angle like angle ABC. This angle here is the central angle, and therefore the the vertex being B. And so over here we also have some examples of central angles like angle 1, angle 2, angle 3. All of those have a vertex that is the center of the circle. That's the first thing you have to have for a central angle. But also its sides contain two radii of the circle. So we're talking about this angle here, and so the two sides of the angle, side AB and side CB, are both radiuses or radii of the circle. The same is true for examples or angles 1, 2, and 3 here. In angle 1, this is one side, that's the other side, so they're both radii. Here we also have two radii for angle 2 and then two radii for angle 3. So just so that we understand what a central angle is. And so because we know that the angles in a circle, because we know that the degrees in a circle are 360, we know that if you add up all of the central angles of a circle, then it should also add up to 360. So that's what your first key concept is here. The sum of the measures of the central angles of a circle with no interior points in common, so they can't be overlapping, and in this case they're not. Then if that's the case, then their sum is going to add up to 360. It doesn't have to be 3, it could be 2, it could be 5, as long as all the central angles with no overlapping parts add up to 360. So we're going to go to our first example, and it says here find the value of x. And so what we're going to be doing here is first, we know that all of the central angles should add up to 360. So we're going to start by saying that the measurement of angle GFH plus the measurement of angle, so I'm going GFH, that would be this angle here. So I'm going to go to this angle, which is HFJ. So plus measurement of angle HFJ. And then we add that to the angle JFG. Should all equal 360. And then we're going to use some substitution because we know from the diagram that GFH, angle GFH, measures 130 degrees. And we know from the diagram that angle HFJ measures 90 degrees because it's marked with a 90-degree symbol. And then we don't know what angle JFG is, but it is labeled X, so we replace it with an X. And now we have our equation, and solving it is not very difficult. We need to subtract the 130 and the 90 from both sides, and we'll just go ahead and do that at the same time. And so our final result would be that x is equal to 140 degrees. And so that is how you can find the measure of a central angle. So we're going to let you do it yourself, number 1 here for part A and part B, and then we will go on to our next item of business, which is an arc. An arc is a portion of a circle that is defined by two endpoints, and sometimes that can be confusing because with the same two endpoints you can have different arcs. So you can see here that you've got an arc that has endpoint P and R. So the red one here is an arc, but also the same endpoints make this blue arc. So just so that we know, we have some descriptions here, and we're going to go ahead and move this out of your way so that you can see that better. But basically, a central angle separates the circle into two arcs with measures related to the measure of the central angle. That might sound a little complicated, but here hopefully it'll get a little bit more clear for you. We have 3 different types of arcs. We have a minor arc, a major arc, and what we call a semicircle, which is basically an arc that measures half the circle, right? But technically a minor arc is the shortest arc connecting two endpoints on a circle. So in this case, up here, it would be the red part because that's the shortest distance. A minor arc is always less than 180 degrees, and so its measure is going to equal the same as the central angle. So that's what this is saying. This is saying the measurement of arc AB, so you'll notice the notation, when you're talking about the arc, you're talking about the red portion on the circle versus the degree measure of the angle. Okay, but in the case of a minor arc, this would be equivalent to the measurement of the angle measure here. So the arc is equal to the angle measure, which is x in this diagram. Okay, a major arc is the longest arc connecting the two endpoints, so it would be the blue one here. So that one is going to be always greater than 180. So to get its angle measure, you would take 360 and subtract the smaller or the central angle. So notice here that it says the measurement of the angle ADB. Also notice that with major arcs, we use 3 letters so that it's very clear that when you say AB, you're not going AB, you're going the shortest distance AB. But notice that with the major arc, we have 3 letters so that you don't go AB, which would be the short one again, you go A to D to B. It kind of makes sure that you don't go the wrong direction with the major arcs. So they usually use 3 letters to describe a major arc. But a major arc will be the entire circle, so 360 degrees, and then you subtract the central angle, which is the x up here, which is the same as this one. Okay, so in this case, the arc, the short arc, the minor arc, is equal to x, but in this case, in the major arc case, you're going to take 360 and subtract x to get your major arc length, okay? So for the semicircle is an arc with endpoints that both lie on the diameter. So, and that way it doesn't matter if you go either direction because it's a semicircle. So in the case of a semicircle, its measure is always going to be 180. So those are the different types of arcs that we have. So we are going to go ahead and move this back down here. Sorry about that. And go to example 2. And in example 2, we have a very limited space. But example 2 says segment GJ is a diameter, and I didn't even spell diameter right there, sorry, but is a diameter of circle K. Identify each arc as a major arc, minor arc, or a semicircle. Then find its measure. So part A, we're looking at arc GH. So arc GH is right here, and because it's not bigger than 180, it's actually less than 180, we can classify it as a minor arc. And in the case of a minor arc, it's equal to its central angle, which is marked as 122. So in this case, the measurement of arc GH is equivalent to the angle GKH, which is equal to 122 degrees. Alrighty, so then we have part B, measurement angle GLH. Notice the 3 letters, so we're going from G to L all the way to H, and that's bigger than 180, so it's going to be a major arc. I'm going to use a different color to kind of separate my writing here so you don't confuse. This is part A. So my major arc is going to be 360 is equal to 360 minus the central angle, which is 122. So it's going to be 238 degrees. The measurement of arc GLH is equal to the entire circle minus the central angle, which was GKH. So that would equal 238. I hope that makes sense. And then in part C, we're doing GLJ. And here's GL to J. And that's actually a semicircle. So with a semicircle, we know that a semicircle always has a measure of 180. So we'll just go ahead and say that the measurement of arc GLJ will equal 180. Alrighty, so that's example 2. So now you can do it yourself number 2, part A, B, and C. And then we will move on to our next concept here. We talked about arcs, so now we're talking about congruent arcs. Congruent arcs are arcs that are in the same or congruent circles that have the same measure. So you can be in 2 different circles as long as the 2 circles are congruent, or you can be in the same circle and have the same measure as well, okay? That would be that you're a congruent arc. So in example 3, we have refer to the circle graph, which is over here on the right, and it says find each measure. So I want the measurement of arc CD, and so when I come to my graph, my circle graph, I can see that arc CD is this portion right here, and it's labeled as 18%. That means that it's 18% of the entire circle. And we know that the entire circle has to have 360 degrees. So we're going to go ahead and say that the measurement of the measurement of arc CD is going to be 18% of the angle measure, not the angle measure, 18% of the entire circle, which is 360 degrees. Alrighty, and since we know that 18% needs to be a decimal, we're going to go 0.18 times 360, and when you multiply 0.18 times 360, you will get 64.8. So the measurement of arc CD is 64.8. Now, for the measurement of arc BC for part B, what we notice is that when you look at the graph, you have that track and field, which is BC, has the same percentage as volleyball, which was CD. They're both 18%, and since we just calculated that 18% of the entire circle is 64.8, then because the measurement of arc BC has to equal the measurement of arc CD, which we just calculated to be 64.8. They are congruent arcs and therefore have the same measure, so they're both going to be 64.8. Alrighty, so now you can do it yourself number 3. It's down here, it's kind of hard to see, but it is there. You're going to try to find the measurement of arc EF and the measurement of arc FA. Once you've done that, then we can move on to the next item here, which is adjacent arcs. And you guys know what the word adjacent means. It basically means next to. We've had adjacent angles in the past, so adjacent arcs are very similar to adjacent angles. But here we have a definition and your postulate. And basically, adjacent arcs are arcs that are in a circle that have exactly one point in common. So in circle M, which is over here, just to give you an example or an idea of what's going on, in circle M, arc HJ, which is right here, and arc JK, which is right here, are adjacent arcs. So the point that they have in common is J. They only have J in common. Alrighty, so that would be, for example, if I'm looking at this guy here, if I went from arc BCD and then arc CDE, they would have 2 points in common. So they're overlapping. That is not adjacent arcs. So they can only have 1 point in common. And as with adjacent angles, like we did in the past, you can add the measures of adjacent arcs, all right, so that you can get the whole. So as you can see here, that's what we've got here. The arc XYZ, which is XYZ, can be added by taking XY and adding YZ to it to get the whole. So the 2 parts will equal the whole. So in example 4, we're going to do just that. And it says find each measure in circle F. And we want first the measurement of angle AED. So here we have the measurement of angle AED. We want to take these pieces here. So we have basically AED, we have 2 adjacent arcs there. So we have arc AE and arc ED. So we're going to say that this is going to be equivalent to the measurement of arc AE plus the measurement of arc ED. But from the diagram, since we know that arc AE is 63, and we know that arc ED is 90, then we can add them together and we get 90 plus 63 is going to be 153. And so our answer for part A is 153. All right, and so then we're going to go to part B, which is ADB. And there's a lot of ways that when you go to A to D to B, you can take all the pieces, this piece, that piece, that piece, that piece, and then add them all together to equal the whole. But since we don't know a lot of these pieces, there's a couple of different ways that you can break it up. But I think the easiest way to do this is to recognize that from A to E, we know that that's 63. So we're going to say this is equal to the arc AE again. And instead of breaking up all these three pieces, we can recognize that these three pieces are a semicircle. So we're going to go from E all the way to B. So we're going to say, now we have to give it a third letter so that we know when we say E to B, we're not talking about E to B this direction. So we're going to say EDB, but you could also say ECB. But I'm going to say plus the measurement of arc EDB, like that. So I've got my AE, which I know is 63. And then I'm going to add my arc EDB, which I know is a semicircle. So we're just going to add 180, and then my total is going to be 243. Easy peasy. So now you can try to do it yourself number 4, and then we will go to our last concept and do it yourself question, and that would be arc length. Now arc length is the distance between the endpoints along an arc, but unlike what we've been doing where we're measuring it in degrees, you're measuring it in linear units. So the best way to think about it is as a proportion of the whole, okay? So basically it's a proportion of the circumference. We know that the circumference is 2 pi r. That's been the formula for circumference for a long time, 2 pi r. And so what's happening is we're taking the fraction of the whole that you actually have, which is kind of what you see here, x over 360. For example, if I had 180 as my x value here, just pretend here that this was 180, then that would be 180 over 360, which is 1/2. So it would be saying that it's half of the circle's circumference. So if I know the circle's circumference, then the arc length of half the circle would just be half of the circumference. So all this fraction is telling you in the beginning is what fraction of the whole you actually have. So I hope that makes sense. And if it doesn't, maybe in the next example it will. So here is example 5. And so it says find the length of arc ZY, round to the nearest hundredth. So first of all, we can do this and just figure out what is the circumference of this circle. The circumference of the circle is going to be 2 pi r. So it's going to be 2 pi times the radius, which in this case, excuse me, the radius in this case is 4 inches. So the circumference of this circle is basically 8 pi. That's the circumference. But I only want this portion of the circle. So what portion of the circle is that piece? So because it told us that it was 75 degrees, it's 75 out of 360 degrees. That's the portion that it is. So that fraction actually reduces to 5 over 24. So basically I'm going to multiply my circumference by the fraction 5 over 24. Now at this point you can get the exact answer, figure that 8 and 24 cancel, and you get 5 pi over 3 as an exact answer. And that's what I like, of course. But, you know, I'm not going to be crazy. The book is allowing you, and it says to round to the nearest hundredth. So 5 pi over 3 is roughly 5.24 inches. That would be the arc length. So now it's not measured in degrees, it's measured in linear units. And that's the difference between finding the measures of the arcs in the previous examples and finding arc length. Alrighty, so for this look, I do the same thing. We're going to take 130 degrees here, because they want us to find ZY, which is this piece here. So it's 130 out of 360. times 2 pi, and the radius in this case, the diameter is 10 centimeters. That means the radius is 5 centimeters because it's half of that. So you basically get 130 over 360 reduces to 13 over 36. You can just drop those zeros. And then 5 times 2 is 10 pi. So you can get the exact answer, but approximately it's going to be 11.34 centimeters. And then lastly, for part C, we'll come over here in different colors so we're not confusing with what's already there. But again, you have the same angle measure that you had in part A. So it's going to be 5 over 24 as well. Remember that the 75 over 360 reduced to 5 over 24. But this time we're multiplying it by 2 pi r, and in this case the radius is 6 inches. So you're actually going to get 5 over 24 times 12 pi. And again, 12 goes to 12 once, 12 goes to 24 twice. The exact answer is 5 pi over 2. That makes me happy. But when you round it to the nearest hundred, you get 7.85 inches. And so there's your answer. And we should probably circle our other answers here, 5.24. Make sure that your units are always correct. Centimeters in this case, inches in part A, and in part C also inches. Alrighty, so that is how you find the arc length. So now you will do your last do-it-yourself question for this video. And once you have completed this do-it-yourself question, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.